Yeah. Do you have a view on the screen? No, you don't. Can you see there? Yeah. Okay, all right. Okay.
Yep, it's all yours.
Good morning, ladies and gentlemen. It's quite an honor to be here today. So our presentation today, it's actually more like a discussion that I hope that we're going to have, is on the importance of power grids in achieving net zero. So first we'll talk a little bit about global warming, and you probably have heard a lot about this, but I just want to reinforce the importance of talking about global warming, that we are all on the same page. So what's the situation at present? Man-made greenhouse gas emissions are causing a global temperature with a resulting effects on extreme weather events. For a long time now, we already know that the global warming has increased by more than 1%. So, but this warming trend has been accelerated in recent years. So this is an interesting curve, which I would like to see, is that it goes back millions of years, but look at the last 12,000 years there. You can see the temperature is flat. And 12,000 years, that's the time that Homo sapiens actually came to be. So during the whole time that we are on this earth, Homo sapiens, temperature was flat. And it's only in the last little bit you'll see that there's a slight increase in the temperature, which this next slide will show very well. So from 1850, start of Industrial Revolution, you see this constant rise of the global temperature. And I just want to point out that 10 years ago, in 2013, the temperature rise was about 0.8 degrees. Now, in the last week, actually, in Bonn, they had this this meeting of the this is small to read for me, but you probably can read it from the screen. And this is preliminary to the next COP presentation or going. And they found so far today that in the last decade, global temperature has increased by 1.2 degrees. 1.2 degrees. 10 years ago, according to the previous chart, if you go back there, 10 years ago, it was about 0.8. So if you add those 1.2 plus 0.8, we're already at 2 degrees now. And we're 2023, and we're not even. End of the century, that's what the Paris Agreement says, you know. We try to get 1.5, but you know, trying to achieve 1.5, but we hope to be limiting 2 degrees by the end of the century. And here we are, 2023, and we are already more or less hitting that 2 degree mark. So that is very, very frightening. So here, shortly, you can see what the agreements were, you know, from the Paris Agreement, which was done in 2015. So 1.5 degrees, we're hoping to achieve that. They were hoping to achieve that, but the aim was to limit to 2 degrees by the end of the century. And the commitments by the United States and Canada is that we will get there by 2050, the net zero emissions. But in the power sector, the commitment is that we will hit net zero emissions by 2035. So how are we doing presently? So the global warming, just explained it, that we're hitting 2 degrees, so that's not very good. And sorry, we can only what we're going to do to try to improve, you know. I mean, even if we exceed 2 degrees, any bit of decrease that we can achieve will have an effect on the number of life saves and so forth. So you can't just abandon it because we can't reach the goal. And this is, I think this is an interesting little illustration. You've heard of the 4 riders of the apocalypse, of course, which is the, you know, the famine, death, pestilence, war. And there's a 5th one, I think there is, which is misinformation. Because how many, you hear in the news and so forth, oh, there's global warming. But what is being done about it? When you realize the catastrophic consequences of global warming. We've never had it so hot. We don't know what 2 or 3 degrees will achieve. You see all these extreme events that are happening. You see what happened in New York City a week or 2 ago. You know, how many people will die because of that? So we don't seem to be, as a society, we don't seem to be actively pursuing this problem and saying, okay, the solution will come, but we don't see really any big advances in that. So we want to have net zero emissions by 2035 in the power sector. So the power sector is a main, I should have a text here, you know, but it's the power sector, the main contributor to greenhouse gas emissions is coal. And the total power sector is responsible for about 40% of global emissions. So that's quite a lot, 40%. So in this shift to energy resources, the first thing we have to do is get rid of coal for generating purposes. Together, China and India, they account for 66% of the global consumption and emit about 35% of the world greenhouse gases. If you add the United States to that, this goes up to 72% of coal consumption and 50% of the greenhouse gas emissions. Now this chart is interesting because it shows the global coal power capacity added or retired. So in blue is the coal power capacity over the whole world, which is added. And in red is how we retire. And you can see where, if you can see the little black crosses in the blue zones, that's the net, that's the blue minus the red there. So you can see it being reduced there to almost zero there at the end, and that's 2021 or 22. But there suddenly, big event happens, Ukraine war, you know. So of course then now this changes the whole picture of energy supply and so forth. And people, nations, they use coal because it's cheap, right? So they have no choice. They have to increase their coal-fired generation. And this is going, forget it about going down again. We're going up again. So we have not reduced, we have not managed to reduce coal-fired generation in the Paris Agreement was 2015. Here we are 8 years later and nothing has happened. And it doesn't look good for the future now, because especially after Ukraine, you saw that dam that was attacked and broke down. So that brings in famine. There's going to be a lack of food over the whole world. And that lack of food, of course, will translate into population shifts, people trying to emigrate to where it's better, which causes problems in its own. You see Europe, you see the United States. This is not looking very good. So this is from the United States. It shows solar and wind, for instance. It's basically the renewables in green. But by 2050, you'll see you still have a large percentage of coal-fired generation. And you have still natural gas, so these are all greenhouse gas emissions. But we don't, and demand, of course, is increasing, not only because of the previous presentation, but demand is increasing with electrical vehicles and so forth and so forth. Actually, there's this report from NERC, the National Electric Reliability that of all the countries, of all the states and all the provinces of Canada and the United States, in BC we have the largest increase in demand, so 6.8% over last year. So that's pretty big. We need to have reliability of these for the interregional links. We're talking about transmission now, and interregional links. Let me just go forward. I think I may have, okay. Did I jump something? No, all right. So what do? We have a lot of renewable energy coming online. We have solar, we have wind. So these are the things that we're counting on to replace this disappearance of coal-fired electricity. The problem with these renewables is that, of course, when the sun doesn't shine, you have no electricity. And when the wind doesn't blow, you have no electricity. So you need something to back up. And I'm talking a big, big backup, to when these events happen. And of course, you have batteries. Eventually, you'll have hydrogen. But batteries, for the moment, they last about 4 hours. So if there's a long event, interruptible event, batteries are not going to save the day. But the one thing that you have is interregional links, and there's more and more attention being paid to these long interregional links. That they go from a place, from one place to another. So the hope is that if you don't have wind here, you might have wind somewhere else, and so you can import those renewable generations. Now, these big links, they're going to be high voltage direct current. High voltage direct current is after a certain distance, 500, 600 kilometers, high voltage direct current will be cheaper than alternating current, and they are much easier to control. So also after this, the recent winter storm Elliott, FERC and NERC, they launched an investigation, and they say there's a need for the electric sector to change its planning. Planning in the utilities usually was done on statistical basis. You know, how many outages did you have and so forth. You can't do that anymore. With all these extreme events, you have to plan for a possibility, and that's a big change in the planning of utilities. So the past events are not a good indication for the future. I remember when they had this big storm in Florida, they were talking about a 1 in 500 year occurrence. But based on what data? You can't based on statistics. Can you say that such a storm will not happen again in 500 years? No, of course not. Statistics are out of the window here. So reliability planning should be scenario-based and not probabilistic-based. What is the most worrisome scenario? And one thing that I want to show, and this is slowly coming, is bury the HVDC transmission line. Look at what happened in Quebec, and I'm not sure how many are here from Quebec, but you know during that, during what happened there a couple of weeks ago with all the forest fires, and then the big situation that happened in New York. What happened when with these forest fires, the pollution settles on the insulated strings of transmission lines, and it will cause outages. And from my contacts in Quebec, I know that they had many outages, not outages of the system, but transmission line outages. And you probably experience these voltage dips, that suddenly voltage collapses and then comes back right on the way, which is caused by, if you have a transmission line tripping, of course, then the impedance gets higher and suddenly the voltage drops, you know, but then voltage regulators work and bring the voltage back up. But if you have like an HVDC line of 2,000, 3,000 megawatt, if such a line would trip, I can tell you, your system is going down. And you have to, of course, if you have a lot of HVDC lines, like a big macro grid, you can plan for that, for a line being out of service without tripping the whole system. But in the beginning, for sure, you're going to have a system outage. So you have to protect those transmission lines. those 2,000, 3,000 megawatt transmission lines. This is one line that goes from New York, from Quebec to New York City. It's called the Champlain-Hudson Express Transmission Line, and it's buried. It uses the lakes, it uses right-of-way in the roads and so forth, but this makes it immune to events like the forest fires. Makes it also immune to hurricanes. It makes it immune to flooding. It makes it immune to how do you call that? Outages through blasts in the atmosphere, you know, that electromagnetic outages. So and what it does actually is it saves you from having a system outage. A system outage costs billions of dollars, and actually, in that case, New York, they calculated that they could save $25 billion, you know, in the first 25 years just by burying that line. And of course, burying a line is more expensive than an overhead line, but the cost of that, the difference of cost is pales compared to the cost of system outages and human life. Also, the one thing that helped going underground is that, for example, there was a transmission line planned from Quebec through Maine to Massachusetts. That line, they had so much trouble getting permitting, so all the landowners have to agree, and they had started construction, but then the construction stopped because they made a vote in Maine, and most of the votes were against the line, so the construction stopped. Now, this is still ongoing. They went to the court, and next month there will be another court session. So, but if it takes 10 years, 12 years, you know, it's not unusual to obtain permitting, the authorization to build a line. And that's one good reason to bury the line, because it will drastically reduce those big lead lines required for permitting. There's another, the Sioux Green, the transmission line, HVDC line, which links in the middle of the state somewhere, going to Chicago. There you can see on the right side of the railroad, it's Canadian Pacific Railway. That's where they buried the power line there, and it's a multi-megawatt line, and that's going ahead. And also, I can say that in Europe, they're much more advanced in this topic. For instance, in Germany, all HVDC lines are buried now. There's no overhead lines anymore. So this is the way to go, as far as I'm concerned, is the future of HVDC transmission. Yeah, so this is the end of my remarks. Ken, do you have something to add?
Thank you, Guy. Thank you, Guy. My name is Ken Putt, and I'm not an electrical engineer or a specialist. I'm a generalist, but my skill is connecting the dots. So in an example, Guy was invited to make a presentation to the American Council of Renewable Energy. And when I participated in viewing that online, and they were enthusiastic, and they pointed out that they were bringing that to the attention of the Biden White House prior to the meeting of Biden and Prime Minister Trudeau a couple of months ago. And so I took Guy's presentation and got it through my board connections to the ADM level of NRCan and the connection between Global Affairs Canada. They're head of the Canada-American relations, and to try and get the message out. So one of the challenges we have is integrated power system planning. And in the US, for example, right now, there's so many projects backed up. The entire generation capacity of the US is in a backlog of renewable power projects because they don't have integrated planning, they don't have the power engineers to do the assessments, and so In Canada, we haven't made any steps forward for integrated planning. And that's one of the key issues is not the technology, it's the policies. And so the government of Canada, as a result of the Biden Trudeau conversation, just created a Canada Electricity Advisory Council or Committee. But I looked at the terms of reference, and there's nothing in the terms of reference that they have to live within existing regulations. And one of the problems is when the government put in Bill 69 to block pipelines, it also blocks major power transmission systems. So that committee needs to address policy constraints, not just the technical issues. So there's a lot of public policy issues that have to be addressed to have integrated planning between the provinces. And because generation is provincial, not federal, the federal government is derelict in not bringing the provinces together to collaborate on integrated planning. And so that's one of the challenges our country has. And the U.S., FERC has taken leadership role in integrating planning between the states, and it's even more complex down there. But in Canada, we're not doing anything. So our challenge, I think, as the Canadian Academy is not just the technology, but to push forward the need for integrated planning and policy to support the grid, because, for example, in the U.S., electricity demand is going to go up 75% between now and 2050. In the world, it's 76%, but the Canada Energy Regulatory Agency just came out with a report yesterday that said there's 3 scenarios in Canada. One is the world reaches net zero by 2050. The next is the world doesn't, but Canada reaches net zero by 2050. And the third is trends continued. And in the world net 50 case, the electricity demand goes up by about 120%. And in the Canada net 50, but the world doesn't, their electricity demand goes up by 130 some odd percent. So we've got huge challenges in growing the grid and integrating the grid between provinces and addressing those huge demand burdens that are coming. But one of the issues is the government is good at kind of supporting electric vehicles, and they're just put $30 billion into battery plant in Ford and maybe another $30 billion into the Volkswagen plant in southwestern Ontario. But when the ACOR group of the U.S. worked with the energy producers of the Maritimes, they put together a plan where Ontario, Quebec, the Maritimes, Newfoundland, Labrador, and New England states and New York State would put together a consortium to do integrated planning. They couldn't agree on who would fund it, so it would just take a minuscule amount of money to fund an initiative like that. Would have integrated planning across Ontario, Quebec, the Maritimes, Newfoundland, and New England and New York State. So the government is very quick to put huge billions of dollars in some initiatives, but nothing in supporting integrating the system or moving the grid forward. So we have some major challenges in the country to address at the policy level, and small amounts of money in the right place can really facilitate moving things like the macro grid forward and moving other initiatives that are fundamental underpinnings of getting to net zero. We can't get to net zero without putting the infrastructure in place, and we need to think of it from a system standpoint, not a one-off, one province, not north-south only. And we also need to look at the generation differently, such as using hydro as a giant battery And having, using HVDC, right, I think in Pape Salmon's talk yesterday, he showed load shedding from wind and solar. Right now in California, there's dumping of surplus power during the midday, and so that power could be transmitted by HVDC to BC and keep the water behind the dam. And then in high demand periods in California, when there's not enough wind or in the evening, early evening when it's dark, that power could be reconveyed south to California. So we need to think it, and that same interprovincially, we can use it for time shifting, so demand shifting and time. So we need to think of these things on a system-wide basis and need to look at integrated planning and not all the kind of silos. So that's my comment. Thank you. We'll have some time.
If you don't mind, I'll come up and sort of
Sure.
just take questions. And,
Yeah.
Yeah, of course, yeah.
Yeah, let's do it that way. Sohail, please.
When it comes to net zero, really there are two scenarios we are working with. The first one is electrification that you just mentioned. And actually, to be honest with you, I think that is the most feasible option, doing the electrification, which require, by the way, at least 250% increase in terms of the system that we want to build. And I agree with you in terms of using direct current is the way to go. But the other system that is right now, there's lots of pressure and is growing, I guess, support is hydrogen economy. So I just wanted your opinion in kind of talking about the challenges that we have in both sides of the equations. To me, the challenges of electrification is actually the challenge that our provinces are not collaborating with each other. This is the major. It's not a technical or technology challenge, whereas the hydrogen is more like technology challenge. So just your comments. Thank you.
Go ahead, Guy.
I do think that we should not concentrate on one technology alone. We have to concentrate on all technologies which have a positive outcome, whether it's hydrogen or making microgrids, to help the distribution of electricity in load centers, or even nuclear, the small nuclear reactors. I mean, these are all options, and that we should not discard any of these in favor of one. We probably will need all of them if we want to be able to meet that big increasing demand that we're going to have.
Yeah, no, I agree 100% with you, but the hydrogen economy says we build everything based on hydrogen. That is a different scenario. Whereas electrification says that we are doing transportation of energy through building a robust grid system. So there are kind of a big difference in terms of the two approaches. Your point of taking and using all technologies is well taken. We have to. There's no questions about it. It's about the big system that we are building. Is this going to be major by using electrification, or are we going to use what we call hydrogen economy, which essentially says, you know what, we are going to build stations everywhere, and all we are going to be doing is transporting hydrogen, and that is going to be our future. Thanks.
Yeah. I think time will tell.
Sorry, yes, go ahead, David.
I just wanted to comment on that. I don't think the hydrogen economy and the electrical grid are two separate things. They're actually integrated. We're looking at opportunities at the intersection point of the grid system, pipelines, and reservoir system. So basically, I think they're very complementary, and to have a real hydrogen economy, you have to have a very good grid system as well, as Germany has found out. So, because they're very far along in setting a national grid system. So I don't see them respectfully disagree with the
If I may make also an additional comment, is that some people tend to say, oh, we should only favor green hydrogen, and I don't think that's the proper way to go. We need every bit, of help that we can have. So blue hydrogen, which is made by storing carbon underground there, is still an option. It's a big revenue generating for Alberta, for Canada. We should not throw that out of the window, because we need all the energy we can get. And as long as there's coal being produced, using natural gas is going to help. Reduce that use of coal, and that's really the first priority.
Guy Guri has a comment here.
Yes, I just have some comment here. I think in 2010 and 2011, as part of the CAE Energy Pathway Task Force, I was involved with Clement and Bowman, and CAE proposed basically program to the federal government, particularly in the context of Canadian planning, pan-Canadian national grid integrated planning process, with an objective that definitely some of those interprovincial links, how to strengthen the interprovincial links, the grid, particularly to increase the uptake of renewables across the Canadian context. Also, considering all the, I think, some of those opportunity in various other provinces like Quebec and Ontario as well as East, and the time difference between the how to basically capitalize some of those excess so-called power, hydropower on the other regions to the west and also mid of the countries. But I think that is the probably important aspect. I agree what you are saying with respect to lack of interprovincial integrated planning process on the electricity networks. I think it remains a critical challenge for us, and given those provincial energy jurisdiction, I think dialogue needs to take place in the, perhaps the CAE needs to take that, revisit that issue again, and perhaps have this conversation. I'm not in that organization, but that time the Power Tech Lab led that through the CAE, that initiatives, and that time I was actually leading that initiative when I was at Power Tech Lab, and at that point, we did receive the collaboration for all the basically utilities across the Canadian context from the west to east. I think on that particular CAE project, I think we need to revisit that things, and perhaps with your leadership or whoever it is leading, similar approach should be taken again.
I think it's very sad, that amongst provinces we can't agree on making these interconnections. There were negotiations between Quebec and Ontario, which didn't result in any firm agreement on a big link. Of course, there's the situation between Quebec and Newfoundland that doesn't help really very much.
In the same sea in Alberta.
In the West, we had negotiations between BC and Alberta about using the Site C hydro plant, which is still not finished, by the way, bringing that power to reduce the thermal generation in Alberta. These negotiations went on, and they didn't. They agreed to disagree. So that, and actually, even here on the island, we had negotiations between Victoria and Port Angeles on the other side of the island, and all these negotiations were successful, except politically there was a block. So it's from a political aspect, there should be something that can be done, to make people realize that, there's something more important than just to say, oh, we want what's the best for our province. We have to develop win-win situations. When you do that, it doesn't matter who has the most to win, Win-win situation is a win-win situation.
Guy, can I just, I just want to add I'm supposed to be the moderator, but let me add a quick word. For various odd reasons, I sit on what's called the CSA scope, which is the standards committee that develops part 3 of the electrical code, so transmission and distribution. I'm there for electromagnetic compatibility reasons, but everybody else on there is the senior standards person for a utility. And so it is that they're trying to collaborate. They're trying to collaborate now on resilience, adaption, new technology integration, because a lot of the technologies are accepted within an individual utility without actually referencing a national standard. So they're working at it, but it's a tough one, right? And so I sit there thinking about this from the perspective of the academy. I don't, as much as I have great faith in the power of the academy, constitutional change is not within my scope, right? So you've got to pick the battles you can win. And, there's some very interesting stories about the shifting ownership within Canada of each of the provincial utilities. And part of the problem is the ownership models are the most different between adjacent utilities. And so finding these common grounds, and we were sitting there just last week, and they were saying, we have been under provincial legislation to minimize cost for ratepayers for the last 25 years. So every time we had to replace a pole-top transformer, we replaced it with the lowest cost one that met the spec. Yeah. And now all these electric vehicles turn up, and none of them have the capacity, none of our new systems have the capacity for the new cars. Yeah. And they said, and one of them actually had the nerve to say, how could we have seen this coming? Right? So I thought, here's a good role for the academy. Number one, let's give them an idea that it's coming. But the other one is, and this was very much to Ken's point, the academy can talk about things that the politicians find boring. Right? So negotiations between provinces on cost points they'll probably have to figure that one out for themselves. Promoting the idea that integrated planning would go along, just look to 2035. If you don't start integrated planning now, you're not going to get there. Right. If you don't start building HVDC and burying it, you're not going to get there, right? So these are not exciting things, but I think it's the kind of advice that the academy can give that raises the public profile of some stuff that otherwise the politicians might not focus on.
Yeah, I agree.
I think we should make a submission to the new Canada Electricity Advisory Committee as a start.
Yep.
We're looking at some really frightening changes with global warming. So this moment is very crucial, and it reminds me of the end of the World War, when a Marshall Plan was developed to tackle an enormous problem. And we probably need something like a Marshall Plan, to address this global warming problem that we're having right now.
I think of this letter coming from the CAE, and the opening sentence would be, if climate change were real, what you should be doing.
Yeah.
Okay, are there any other questions?
Perhaps just a comment. Perhaps I was able to find that 2010 CAE proposal to the federal government in this integrated planning context.
Yes, please do.
But it needs to be pursued by somebody, perhaps from Power-Tech Labs or from the Seattle. I could find out that things, but I'm not really actually part of Power-Tech now. But I will track down the proposal from CAE, and I will pass on to you. Perhaps we can discuss that.
That'd be great. Thank you so much, Corey.
Good. One comment on integrated planning also is Guy is on the Western Electricity Coordinating Council for based in Salt Lake City, which is all the western states and BC. And when they coordinate electricity, but they don't coordinate planning. And in fact, when the BC Hydro was asked for their demand, they said that's proprietary, they wouldn't share it. So you can't do integrated planning unless the players agree to share their data and their assumptions and their supply and demand views. So it's, we've got a long way to go to get cooperation and collaboration.
Yeah. And this is a final comment. I mean, this is one of these great areas where, sure, giving some federal advice might be an idea, but in fact, this is advice we need to be giving directly at a provincial
Yes.
level. So,
Because the provinces are really responsible, so the federal government is trying to do something, but they're not doing enough. But the provinces need to work together, which they're not doing at all.
okay. You know, I think we're just a couple of minutes before the break, so if there are no other questions, I'd like to thank Guy and Ken for.
Thanks for putting this on the agenda.